Hello, hello. Can you hear me? Calcul to chat. Are we good? I think we're good. Hope everyone's having a good Sunday. As you can tell from, well, maybe if you read the title, I got my COVID vaccination yesterday. However, not feeling super great today. And I don't know what it is. It could have been that giant breakfast burrito that I ate, that I posted on the Discord. Could be the fact that I ran and did some other exercise in the evening. Hey, Snake Star. But either way, I don't know. Feeling kind of funny. And I'm gonna blame the vaccine. Probably put a tracker in me, you know? Now the American CIA is monitoring me. But I'm going to continue with what I did last time. So again, very famous website released what they think might be what the exam is going to look like. And so I'm going to go over the paper 2 version today. Oh yeah, Snake Star, did you watch the paper 1 video? There's a beast of a question in it. So this is TrainingTowns predicted paper 2. And again, I have no idea how accurate these things are, but we'll see. So let's get this over with before I don't know, throw up or something. So we have an arithmetic sequence, and then the sum of the second and sixth term is 32. And then given that the sum of the first 6 terms is 120, determine the first term and the common difference. So this does seem more complicated than I would say typical papers are. Hey Tofu Char, how's it going? But essentially you can see right now that this is going to be a system because we want to find a first term and a common difference, which is 2 variables, and we're given 2 pieces of information, and each one of these is going to make an equation. So the sum of the second and sixth term is 32, so u2 plus u6 is 32. Now if you write it like this is going to be no good, because now we have like 4 variables. Going well, playing some games, nice. What we should do is we should write u2 and u6 in terms of u1 and the common difference, and that's easy to do. So u2 is just the first term plus a common difference, and then u6 is the first term plus 5 of the common differences. So all of this will simplify into 2u1 plus 6d. Okay, so that's our first equation. And then we know that the sum of the first 6 terms is 120, so that's 20, and then we can just follow the formula which is in your book. This is going to be 20 divided by 2, which is 10, times 2u1 plus n minus 1, n is 20, so 19, d. So this is going to simplify a little bit into 20u1 plus 190d, and this is equal to whatever it said, 120. Okay. D is the common difference, yeah. And then once you're here, we can solve this through a manner of ways. This is a paper 2, so what I can do is I can just graph these and then find the intersection of the graph. And I am going to cheat a tiny bit just to save myself some time. And what I'm going to do is I'm actually not going to use my TI-84 emulator. I'm just going to go to Desmos. But of course, all of this you can do on your graphing calculator. So this is the first equation. 32 equals 2 u1 plus 6d. So I can just literally type it as 32 equals, and I'm just going to change it to x and y. Hello, Jazz. I see you need help, so I'll get to that once I finish off this question. Okay, so here are the two equations I got, of course, in terms of x and y. And then there's my intersection. So x represented u1, so my first term is, I guess, 20.6. And then my y variable, which is d, is negative 1.54. Seems kind of weird, but okay. I mean, my process is correct. I'm sure maybe my numbers are off, and that's why things are looking kind of ugly. But that's okay. Let's not assume that they're not going to be ugly. Because this is a paper 2, so they're allowed to be ugly. So there you go. Okay. Let's go and address Jazz's question. Oh yeah, I got some fried chicken, but I only ate a piece because I don't feel that great. Unable to copy image. Okay, I'll just take a screenshot instead. Mood? What's the mood? Me being not good? Okay, what is this? Which of the following integrals represents this? Fried chicken's a mood? Yeah. Okay. So let's think about what this represents. What you're doing is you are adding up something times something. And this is pretty clearly going to be the width. Because essentially this is just like a, whatever it's called, Riemann Sum, right? You're just adding rectangles together. And then each one of these is going to be a width, 1 over n. And then the length of this is the other thing, which is this thing. So as you can see, if the width is 1 over n and you have n rectangles, then that tells you at the size of your interval. It doesn't tell you where you start yet, but it does tell you that this interval is 1. Okay. What will tell you what your beginning and end intervals are is the first and last of the summation indexes. So if we do this and I plug in I is equal to 1, then it's going to be 1 over n times the square root of cosine like 1 over n. And then we're also going to check out this one, the final part of the sum, which is when I is n. And then you're going to see this becomes the square root of cosine n over n, which is 1. Okay. So because this is the last value right here, this kind of says that your upper boundary of your interval is the x value of 1. And I'm assuming, you know, the way that this works out is there's different kinds of Riemann sums, but this looks like it's a right Riemann sum. Because what you're doing is at the end of it, you're using the x value of 1, which is the right side of the final triangle. You're using that to calculate the height. Why is it 1? Because this was 1. This was the final input. When n, you put it in for I, you get n divided by n, which is 1. And again, this represents the height of your rectangle. So it is the right Riemann sum because we're calculating the height using the right endpoint, not the left endpoint of the rectangle. So if this is the first point right here, well, actually now you don't even need the first point. But as you can see, if you have a thingy of 1 and it's a length of 1, then this has to be 0. So this is so basically this is this integral d, right? Integral from 0 to 1 of square root of cosine x. And at least I'm pretty sure that's what it is. So hopefully that makes sense. Okay. I don't feel super great about this, but yeah. So here's the next question. I've pre-copied them because I don't want you guys seeing the very obvious website that I got them from, but you know, can't let you guys see it. Okay, what is this? Diagram, right angle triangle, ABC, so this is right triangle, sure. And a sector ABD. Okay, so this thing is a sector right here. Circle with center A, yeah, sure. Point E lies on the line AC, so E is on the line AC, such that BE, so when you connect B to E, you make a 90-degree angle, and then the region R is bounded by these things. So this is the region R. Okay, find the angle BAC, giving your answer in radians. Okay, so let's just double check. AB is 5, AC is 12, BC is 12. 13 and 12. Okay. So we need to find the angle BAC, right? So that angle's right here. And that's easy enough to do. This is part of the right triangle. We can just use standard inverse trigonometry. And it's your choice what you want to use. Let's use inverse sine. So let's take the arc sine of opposite, which is 12, over hypotenuse, which is 13. And then this is going to be something. Arc sine of, what did I say it was? 12 over 13? So 8 radians. They're so nice. They asked you to give it in radians. They probably wouldn't do that in an actual exam. So if you put it in degree mode, you messed up. Okay, then we need to find the area of R. So area of R is pretty straightforward. Essentially, it is the area, this region is the area of the sector from ABD. Take away that right triangle from AE. So sector ABD minus the right triangle AEB. So both of these are pretty easy to calculate because we do know what angle A is now. So let's do that. So what is the area of a sector again? Sure, just post them in the Discord. What's the formula for area of a sector? 1/2 theta r squared or something. I feel like this is it. So 1/2 1.18 times 5 squared. Then we need to find the area of the right triangle. To do that, we first should find out this distance AE. Actually, it doesn't really matter. Or we can find the distance BE, because it's a right angle triangle. Let's do that. So let's find the distance BE. So that's just regular trigonometry, which is sine of A is equal to the length BE over 5. So BE is 5 times sine of A. And here's a big brain thing. I don't need to put this into the calculator, because sine of A is already in this diagram. Because instead of looking at the small triangle, we can look at the big triangle. Oops. And instead we can find the ratio of sine A using the big triangle, because I already know what those sides are. This is not necessary, but again, I'm trying to minimize my calculator usage. Remember, sine of A was 12 over 13 if we looked at the big triangle. Big brain. So that's BE. Alright. And then we're going to subtract the area of the triangle. Wait a minute. Shoot. Never mind. You need base times height, and then you divide by 2. So it would have been easier to just find AE. And then I could just use the, 5 times AE times sine A. 1/2 sine A. Okay, I'll do that instead. Not a big deal. So cosine A is equal to AE over 5. So AE is 5 times cosine A. And then that's going to be some number. So that's AE. And then the area of the triangle then is 1/2 times 5 times this length right here. So 5 cosine A times sine A. Okay. So let's put this into a calculator. So I'm going to call this A, because I'm going to use it again. Now, we're going to do 1/2 times A. Wait, 1/2 times A times 25, which is 5 squared. Then we're going to subtract 1/2 what does this say? Okay, 1/2 times 25 times cosine A times, I guess, sine A, sure. So there you go. Putting it all in the calculator, I get 10.3. Not that bad. Okay. Another question for Jazz. What's wrong with this one? This one's pretty straightforward. You did volume of revolution last time. Have you tried graphing these to see what it looks like? So your first graph is just your standard parabola. Then you have y equals 4, which is just a horizontal line. And then x equals 0, which is this line. Let R be the region bounded by these curves. So it's rotated around the y-axis, right? So that just goes this way. Okay, they didn't specify which region is it that's bounded by these three, because there's two regions. There's this one and this one. Not that it matters, but they should be more specific. Because, well, once you rotate it, it doesn't matter. But let's just assume that this is the region. So this is gonna rotate around the y-axis, and then it just makes like a cup shape. Okay, so because you rotate around the y-axis, then it's easier to do an integration in terms of y. So you should be, it's probably going to be one of these two. Because the thing that's changing a lot, right, is the width of this cup, which is an x variable, so you should be integrating with respect to y. Okay, so let's do a couple of things. One, let's find your boundary of integration, which starts down here, and then it goes up to here. So that starts at a y value of 0, and it goes up to a y value of 4, because this line is y equals 4. Okay. Then, this x value is essentially the radius of this circle, right? So we start with this equation, and then easy enough, that means that x is equal to the square root of y. And we'll use the positive version because we're using the positive x. Okay, and then you're basically done, aren't you? This is your radius. So the area of your circle is pi r squared. So it's pi r squared. And then we want to integrate this from 0 to 4, and then you throw in a dy. So shouldn't it just be d? Okay, next one. Oh, it's an interest question. I haven't seen one of these in a while. Okay, on the 1st of January 2021, Fiona decides to take out a bank loan to purchase a new Tesla electric car. Wow, this is so topical. Fiona takes out a loan of P dollars that offers a nominal annual interest rate of 2.6, compounded monthly. The size of Fiona's loan at the end of each year follows a geometric sequence with common ratio alpha. Yeah, the Musk. Find the value of this alpha, giving your answer to 5 significant figures. Okay. So there is a compound interest formula in your formula book. The future value of your loan is the present value times 1 plus the annual interest rate divided by 100. So they're assuming that the rate is as a percentage, so you just convert it to a decimal, and then you also divide this by I guess n, which is the compounding periods, and then this is to the power of n times t. The variables might be off, but this is the format. Okay, so we're assuming that she's not paying back her loan, so then every year it's gonna get worse and worse. Yeah, geometric sequence. Okay. Now here's the thing. What we want to do is we want to find out a geometric sequence. So in other words, we want to find out something that looks like this. Because this is the geometric sequence formula here. So essentially, we're trying to find out this alpha, which is more or less just this part of the exponent, or this part of the power. So alpha is equal to 1 plus, I'm going to convert it right here. So 0.026 divided by 12 to the power of 12. You posted 2 more in Discord? Sure. And then this should be alpha, more or less. I don't think this -1 is going to do anything. Because what's more important is, like, we're trying to find out what you're multiplying by each time. So again, let me just kind of... So alpha should be all of this. Okay, so what is that? 1 plus 0.026 divided by 12 to the power of 12. So 1.03, let's say. Okay, and then what happens next? The bank lets the size of Fiona's loan increase until it becomes triple. Well, of course they would. That means that she has to pay back more money. Once this happens, then the bank demands Fiona pay back the entire amount. That would never happen. They would just let it keep building up. This is a very nice bank. Find the year which Fiona will need to pay back the loan. Okay, so essentially the future value is 3 times the present value. And you can use either formula, the geometric sequence one or the interest one. I would stick with the interest one just because, you know, this is about interest. So what is this? 1.03 to the power t. Although I am going to expedite some processes, right? Because I know that this is 1.03 and then to the power of t. And then I need to find out what power of t this is. Because the present value doesn't really matter, we're essentially just trying to solve this equation. Which does end up being just the geometric one. But solve this for t. And lots of ways to do that. We can do log. And then calculate this out. So log base of 0.103 to the power of 3, 37.17. Now, we need to answer the question properly, which says find the year during which Fiona will need to pay back her loan. So she's gonna pay back her loan after the 37th year is over, because she goes into 0.17 of the next year. So January 2021, you add 37 years, which is like 2058. So she's gonna pay back her loan in 2059. I'm pretty sure. Yeah, so that one's a little tricky with the wording. Just be careful. And the next one looks like a rational function question. Okay. So here's a rational function. Let's find the vertical asymptote. Vertical asymptotes are where you divide by 0 in an SL context. So we divide by 0 at 5, so we have a vertical asymptote at x equals 5. The horizontal asymptote is at the coefficient, the ratio of the coefficients of the x's, so it's 3 over 1. So in other words, we have a horizontal asymptote at 3. Next up, let's find the inverse. So I think this is the function, plus 1. So essentially we're solving for x, and then we can switch the x and y. Some teachers like to teach switching the x and y first. It doesn't really matter. And, you know, you guys should be familiar with finding inverses of rational functions, because it is a fairly standard question. What we do is we multiply this denominator over here. I don't know why I changed colors, but... And then we can distribute the y. This question is easy, wow. And then, of course, we're trying to isolate x, so we collect our x's together. So I'm going to do a little switchy and bring this 3x over, and then move the 5y over to the other side. And then we can combine our x's together, so this just becomes y minus 3x. So therefore, our inverse is this, and then I'm sure they want you to write it in terms of function notation with a variable of x. Yeah, this question should be easy though. And there you go, there's the inverse. Okay, and then write down the range of f. The range of f is the domain. Oh, well, find the range of f inverse. The range of f inverse is the domain of f. And if you're lucky, they will tell you right here. So if the range of the original function, x can't be 5, then the domain of the original function, if x can't be 5, then the range of the inverse means that y cannot be 5. Otherwise, it can be any other number. Okay, and then write the equation of the horizontal asymptote. Well, you can either, again, take the ratio of the x coefficients, but the horizontal asymptote of the inverse is the vertical asymptote of the original. So x equals 5. Now that becomes a horizontal asymptote at y equals 5. Easy peasy. Ooh, linear regression. There will always be a paper 2. Okay, I don't want to say always, but very likely paper 2 is going to have linear regression, because realistically, it's the only time you need a calculator to do this. Okay. So, blah blah blah, you're going to find linear regression of x on y, and then this one's a little bit more complicated, although it's a very standard format. And they will also ask you to regress x on y. So then you need to find a, b, c, and d, and then there's going to be a follow-up which says find the value of the coordinates of the intersection of both lines. So let's do the, this one I actually need my graphing calculator. Okay. You haven't done anything all weekend and you're very sad. Why are you sad? Because you were unproductive? Was it at least restful? Or were you not able to rest because the guilt of not doing anything was eating away like at you? It's okay, I don't feel great either, but that's for other reasons. Yeah, that's the spirit serpent. Be proud that you didn't do anything. Okay, so here's my list 1, my list 2. Remember, first list is x, second list is y. So then we can do a linear regression. And then my x list is list 1, my y list is list 2. This is for the first question where I'm regressing y onto x. Okay, then we calculate. So here's A, there's B. So 2.92 and then 1.75. So 2.92, negative 1.75. And then we just repeat this process again, except now we switch the lists. So my x list is the y list, because we're regressing x onto y. So I just switch these, so the x list is now list 2, the y list is now list 1, and we calculate. So 3.13, 1.08. Okay. You feel really tired for no reason. I don't know, that's just how it is some days. Okay, then you need to find where they intersect, and this is just important to know. If you have the linear regression of x on y, and then you intersect that with the linear regression of y on x, the intersection is at the mean of x comma the mean of y. So what we're going to do is we are going to go calculate two variable stats, because we have two variables, x and y. So my first list, I should change that back to the x's, and then my y list, I'm going to change back to my y list. So here is the average, 6.25, so that's my p-value. And then you can scroll down, and then here are the y's. So here's the average y, which is 16.5. And then you are done this question. This is a very standard question. If you go back into test archives, you'll see questions just like this with different numbers. Okay, and this looks like one of those calculus physics questions. Okay, particle x is moving. Here is the displacement graph. Okay, cool. Find the value of t when the particle first changes direction. So if you think about it, it's starting to the right of something. Like, let's say here's the center, I don't know. So you're starting to the right and you're getting closer to the center, so you're moving closer, closer, closer. So for example, I don't know, let's draw some things for visualization. Let's say that at the center, we have a house. So what this is saying is that you start to the right of the house, and then you're moving closer and closer and closer, closer and closer and closer. And then once you reach the house, you keep walking past the house. And then it's not until this point that you start to return back to the house. No, we will not. So essentially, to find out when the particle first changes direction, we need to find out this x value of this minimum point, which a graphing calculator can do for you quite easily. So let's go back to Desmos, or your graphing calculator, and I'm going to put in this function. So y equals, actually let's call it f of x, because we're probably going to take derivatives later. And this is 24 minus x minus 5x cubed times e to the power of negative 0.6x. So here we are. See, it looks just like it. And then The reason why I'm using Desmos is because it can very easily, it knows what you want. So at 5.28 seconds, that is when it first changes direction. Okay. Then we need to find the total distance traveled by this particle in the first 3.5 seconds. Okay. So essentially, because we have a graph of the displacement, we can just take its initial displacement, so at s of 0, and then, because I know that it changes directions at 5 seconds, at 3.5 seconds it's still going in the same direction, so at some point here is 3.5 seconds. So to find the distance traveled, I just take this one, and then I subtract this one. Final minus initial. So let's do that. So f of 3.5. And then I subtract f at 0. And then I'm just double checking to make sure that I did do the first part right. I mean, this shouldn't change anything. Oh, it did change things. No, it didn't. Oh. I just drew this wrong. At 3.5 seconds, he's past the house. He's like somewhere here. Am I playing Minecraft? No. This is a woozy vaccine edition, so I'm just gonna do this paper and then bounce. So as you can see, if I subtract the two displacements, you can it's negative 29.75, which rounds from 3 sig figs to 30, and it's negative because he's moving to the left. So total distance traveled by the particle, 30 meters. Or centimeters. Okay, and then now we have another particle y. Starts at the same time, and now we have a velocity. And then given that particle x and y start at the same point, find the displacement of particle y. Okay, so the displacement of particle y is going to be the integral of the velocity of particle y. Oh yeah, how I feel? Woozy. I mean, I don't know if it's because of the vaccine. Could have been many things. If you're on the food channel, you saw that it had this massive breakfast burrito at like 12:30. And then I essentially just sat in the sun for like 4 hours. So maybe it's like heat sickness or whatever. And then after that, I went on like a 20-minute run. And then after that, I did some boxing in the park with my friend. And I didn't eat anything after that. But I'm not hungry. So I don't know what it is. Could be a lot of things. But either way, woozy edition today. And unfortunately, I have to wait 2 weeks for this vaccine to like become fully effective. If you feel fine after all that. Normally I think I would feel fine. Unlike other math nerds, I am quite active and healthy. Okay, so let's integrate this. And this is pretty straightforward because you're just integrating a polynomial. Yeah, your dad got it? Nice. Congrats. I'm healthy? I'm quite healthy. Look, when you take the shot, they give you a disclaimer, and they're like, you might feel in the next week these following symptoms: nausea, dizziness, soreness, etc. So I feel like it's pretty par for course. Okay, so we integrate it, we have a constant, and then how we solve the constant is this little piece at the end that says that they start at the same point. So in other words, s of y of 0 is the same as x of x of 0, and we can calculate what this is using the function for x. So f of 0 is 24. So this is equal to 24, and then that means that if we were to plug in 0 for t, c needs to be something so that this is equal to 24, but very nicely, this means that c is equal to 24 itself. Yeah, it doesn't look like it. We have 1 week of this quarter left, and then we move on to the final quarter, the week after. So here is your displacement function in full. Why is he saying he'll miss math? Because his quarter with math is over. And then now he moves on to different courses. However, because IB, you know, is a 2-year program, we've tried to accommodate for all this extra time that they're missing we still have 1 class a week. But like, Vincent's an IB. But like in his quarter with me, I saw him every day for a week, for like 5 weeks out of the 10. But now we're just going down and reducing it to 1 time a week. Okay, and then what is this? Find the other value of t when these particles meet. So because I know both functions, I can graph them, and then I can just find their intersection on a graphing calculator of sorts. So g of x is 5x minus 1/2 x to the power 2 plus 24 . Okay, so if you zoom out, so as you can see, they both start at the same point, and then eventually they will meet at this place at this time. Now the question says find the other value of t, so it wants the time, which is the x variable right here. So that's 12.8 seconds. Jazz is here. How's it going, Jazz? Is RGBT helping you? Okay, what's next? Okay, we have a trigonometry function graph question. So if f of x is 3 times cosine 2x plus 5, and then the range of this graph is p to q, find p and q. Okay, so my students should be able to answer this question. The midline is at 5, and it has an amplitude of 3. So the highest it can be is going to be 8, and the lowest it can be is 2. Easy peasy. Okay, then we throw in function transformations. So g is a function transformation of f. It is going to have a vertical expansion by 4, and then it has something else, which maybe we'll see later. But find the range of g. So the range of g is the vertical expansion by 4 of the range of f. So in other words, the range of g is going to be 4 times 2, which is 8, up until 4 times 8, which is 32. Okay. The function g can be written in this form instead. 12 cosine kx plus c. Find the value of k and c. Okay, so there's a lot of ways to do this, but let's just think about this. This is the midline. The midline was originally 5, and we've vertically expanded this graph by 4. So c should just be 5 times 4, which is 20. And you can do a gut check and see if this is true, because you already know the amplitude is 12. So if I take away 12 from 20, I get 8. And if I add 12 to 20, I should get 32, which I do. Okay. Next up, the value of k. K is the compression, or expansion horizontally. So if you look at f, it has already been compressed by 2. And then if you look at g, we compress it further by 3. So as a total amount of compression, it's by 6, 2 times 3. So k is 6, which means that the period of g is 2 pi over 6, which is just pi over 3. Alright, and then this equation for g has 2 solutions. Find those solutions. Okay, so we have the function. We can just graph it and then solve. So g of x was 12 cosine 6x, whoa, plus, what was it? 20? Yeah. Okay, and then, obviously this is quite cramped, but that's fine. And that's just because of my x-axis. So I am interested in 2 pi over 3 to pi. So I can just change your window. So this becomes 2 pi over 3 to pi. So see, nice and easy. And then let's find out when this function is equal to 10. It should have 2 solutions, which it does, right here and right here. So at 2.52 and then 2.72. Easy peasy. Alright, and then when I was copying and pasting these, I don't include it, but they have difficulty bars for the questions. And these two are the hardest ones in the exam, so I'm not looking forward to them. But we have 2 normally distributed random variables. One has a mean of 70, and the other one has a mean of 80, and they both have the same standard deviation. And then we need to find some value so that the probability of x being greater than this value is the same as the probability of y being less than this value. And we actually did a question like this on my first stream as an affiliate when the Twitch staff member came in. So I don't know if this is just lifted straight out of that one. But essentially we have one standard distribution, and then we have another standard distribution. One of them has an average at 70, and the other one has the average at 80. And we know that they're the same exact sized hump because of the standard deviation. And then we want to find a number, k, so that the area of this is the same as the area of... So this is the probability of x being greater than k. However, the area of this needs to be equal to the other area, which is the area of the random variable y being less than k, which is this orange part. But you can kind of tell just from looking at it that the only way for them to be equal is if k is in the middle. Then both areas will be equal to each other. That's just, you know, the symmetry. So what number is between 70 and 80? K has to be 75. Okay, Jazz needs help. Which question? Both of them? Second one, first one? Jazz, you here? Which one? You stuck on the first one? Oof, this looks gross. So if f of x is this stuff, okay, find f prime at 2. It's not bad, but you need to know, like, fundamental theorem of calculus with, you know, variable boundaries. Okay, so that's just something that you were taught and maybe you forgot. But let's say you have a function, right? And it's an integral from one function of x to a different function of x. So in your example, the lower boundary is x, and then the upper boundary was x plus 2 or something. X squared plus 1. And then, okay, this is going to get a little confusing because there's going to be a bunch of function notations. So let me just ignore this one. Actually, no, you kind of need that one. And then inside the integral, you have, you know, some other expression. So I guess I'll call that f, g, h, I, j. I guess I'll call this j. And then this has its own variable t, dt. Anyways, this is exactly the format of yours, right? You have two functions, x squared plus 1 and just regular x. And then you have this function in terms of t. So fundamental theorem of calculus says that the derivative of f of x is the function j. So, you know, basic fundamental theorem, the derivative and the integral cancel out. And then inside of j, for that variable, you put g of x. And then this, I believe it needs chain rule. So g prime of x. And then this, you subtract j of f of x times chain rule f prime at x. So this might look confusing to you. Is this not the way to do it? You don't think so? This formula she's probably never seen, I guess. You can derive it directly from FDC. You think you've seen it? Way less memorization, I guess. You're allowed your notes? Well, is this in your notes? Otherwise, like, there's no point in this if you didn't learn it. Just write it down. Okay. So again, let's let's write down a couple of things so that you're not getting all over the place. We already know h, we already know g, and let's just write down what j is. J is this stuff, right? So j of t is the square root of, wait, tan inverse of the square root of t squared plus 1 or something. Okay, so if we take the derivative, you can just follow this stuff. So this is equal to tan inverse the square root, and it's t squared, but we're plugging in g of x, so this is now t, this whole thing. Oh wait, no. Oh, this is backwards, my bad. Change this to h. I was not paying attention when I was talking. So change this formula, it should be h's, and then g. Okay, so then this becomes x squared plus 1 squared plus 1, and then chain rule with the derivative of g, which is just 2x, and then you subtract tan inverse of this thing. Right, so g of x is just x, so you're just plugging in x for t, and then the derivative of g of x is, well, the derivative of x, which is just 1. So here is f prime, and then you want to evaluate this at 2, right? So you just plug in 2 for x, and then you should get something. So plug in 2 and then do all of it, and then you'll get an answer. One of these. Yeah, if this is in your notes, then sure. This is just like an extended version of the fundamental theorem, which is what RGPT is saying, is like you can just use regular fundamental theorem. But it does require, you know, a little bit of thought involved. And again, yeah, this is called corollary of part 1 with substitution, whatever it's called. Anyways, where were we? Okay, so we just found out what this is. And then now we know that when p of x is greater than 80, we get this probability. And we need to find theta. So if you ever need to find the mean or the standard deviation of a normally distributed random variable, we will need to standardize it. So for b, I'm going to standardize it. So now this is going to be in terms of z. Now the z score is 80 minus the mean of x, which was 70, divided by the standard deviation. So this is the z score of 80. And of course, standardizing means that the probability is still the same. So this is the same probability. And essentially, we can calculate what the z score is using inverse normal. So this requires a calculator. We go to inverse normal. Our area is this thing. Actually, hold on. Inverse normal only works for an upper boundary. So we might need to do inverse normal on the complement of this, I think. So inverse normal, 1 subtract this number, And then again, this is why you standardize, because you always know the mean and standard deviation of a standardized normal. So here is my z-score, 1.25, which means that 80 minus 70 divided by sigma should be equal to 1.25, which means that sigma is going to be 10 divided by 1.25. So 8. That's a nice number. Okay, and then hence we can find this probability from 87 to 96. And you can find this probability just by using the distribution. You needed to find the standard distribution first, but normal CDF, right? They tell us what our lower bound is. It's 80 something. So lower bound is 87, upper bound is 96, and then the mean was 80 for random variable y, and then standard deviation was 8. So there you go, 0.168. Okay. Then I guarantee this is probably going to switch directions, and now it's going to turn into a binomial distribution, because that's just what IB loves to do. 100 flowers are planted, so you see we have 100 trials, and y measured in whatever, so these flowers have a length related to random variable y. And then if they have a stem leaf between these two values, they're going to be picked and removed. Otherwise, they're going to stay. So find the expected flowers that are going to stay. So the expected number of flowers is going to be, well, there's 100 flowers. I'm not going to write the notation, but there's 100 flowers, right? And you know the probability that a flower is within that length. We calculated that right here. But they want the ones that stay, right? So we take the complement of that. So this is the probability of one flower staying. And then this is how many flowers you have, so multiply those together, and that's how many you should expect. So 83.2 flowers should stay. And then find the probability that at least 90 flowers remain in the garden bed. So that means that we need to find the probability that, I guess we'll call this a different variable, w. At least 90 stay in the bed. So equal to or greater than 90. So in other words, this is the probability. Well, okay, this is a binomial distribution. There's 100 trials, and then we find the probability that, etc. So if at least 90 stay in the bed, then that means that at most, and then I'm going to use y again, that means that at most, we can pick 9 flowers, right? Or 10 flowers. 10 flowers. So hopefully that makes sense. At least 90 flowers staying means that at most we can pick 10. And the reason why I want at most is because we need an upper boundary. And then this is a cumulative binomial distribution. So essentially, we go into our distribution, and then we go all the way down to binomial CDF, and then we have 100 trials. The probability of y, we found it earlier, that was a... Where was it? Oh, it's right here, 0.168. And the most we're allowed to pick is 10. So there you go, this is the probability. Which is 0.0397. This is a cool calculator? Not really, but sure. TI-84 plus silver edition, because it's silver. Okay, what's next? The final question. And this is about basic probability, so my kids that just finished this should be able to do this one. A burger shop sells veggie and chicken burgers. Where's the beef? Each customer will choose one of the following three options. You buy only a veggie burger, you buy only a chicken burger, or you can buy both. So the probability that someone buys a veggie is 0.65, and the probability that they buy a chicken is 0.054. So this very clearly is a Venn diagram. Did I cut my hair? Yes. I cut it right after school on Friday. Well, actually, not right after school, but at 4 o'clock. But I just took a shower, so it's not like... It's like post-shower dyed hair, you know? Dried hair. Post-shower dried hair. Without any product. Doesn't look that great. The calc. Did you know that I could play Minecraft on my calculator? I'm not surprised, to be honest. Because that calculator is quite powerful. But don't... Did you already install it? Good. Well, I mean... Because, well, I mean, I guess you can get like one... You can get like a year and a quarter out of it, but then we have to reset the calculator. Is AI 0.65 times 0.4? This one? Not quite. We're going to fill out this Venn diagram. So if you notice, the probability of buying a veggie burger is 0.65, and the probability of buying a chicken burger is 0.54. If you add these two together, the probability is over 1, and that's because there's an overlap in people that can buy veggie and chicken. So if you have a 0.64 chance of buying a veggie, sorry, 0.65, and there's a 0.54 of getting chicken, notice that this is 0.19 over 1, and probabilities need to be 1. So that means that there is 0.19, a probability of 0.19 of getting both. So that is what this is. Jenny, you're thinking of if you buy a veggie burger and then you buy a second burger, and their independent events. Then you multiply together. Okay, and then what happens if you want to buy only a chicken burger? Well, you know 0.19 of the 0.54 includes veggie, so we just take away the 0.19 from the 0.54. But I don't have the math skills right now to do that, and that's where a calculator comes in. So only chicken, 0.35. Alrighty, and then you know what? Let's fill out the rest of this diagram. So what about only veggie? Same thing. We take 0.65 and then we subtract the ones that also get a chicken. So 0.65 minus 0.19, 0.46. Oh, you know what's the new hot streamer game? It's that like Pictionary game. That's kind of like Among Us. Like Garlic Draw or something. That sounds kind of fun. Yeah, garlic phone. Should we try it out sometime? Although then you guys can see what I'm drawing. Right? Yeah, garlic phone. Scriblio? Okay. Class game. There's no more classes. It's over. Okay, 600 people come to the shop. Find out the expected number of veggie burgers sold. Well, that's easy enough, right? That's just 600 multiplied by the probability of buying a veggie. So whatever this is. So 600 times 0.65, so 390. During flex? I mean, sure. You guys can come in during flexes. You know what I want to do? I want to play more spike ball. We need to set up like a lunchtime league or something. What's this? Jazz has given up? Yeah, spike ball league at lunches. Which one are you doing? Are you doing this one? Find the equation of a line that passes through this point and then is tangent through this graph. Okay. So you know what you need to get the equation of a line, right? You need its slope, which is going to be the tangent slope, and you also need a point on the line. And they tell you that. So what's the big deal? You take the derivative to get the equation of the tangent slope, you plug in x equals 0, and then you're going to get some value. So that's your slope. And then you just put it into point slope form and then redo it. No, that's not the way. What's the big deal? And you can just plug it into this formula. This curve doesn't intersect it? Oh, it doesn't? Oh, it passes through this point. Oh, okay. And wait, find an equation of the line which passes through this point and is tangent to this graph. What? Yeah, that's what I'm saying. This is fine. Oh, you're just being pedantic. Okay, this point is on the line. I'm not saying it's part, it's not, I'm not saying it's on the function. Wait, like you just have, oh, I see what you mean. Oh, I see, yeah. You can't plug in 0 into the derivative because this 0 is not on the thing. I got you. That's pretty lame, man. That's pretty lame. Well, I don't know. You gotta understand that in my mind, at any moment, there's like 5 things happening. 1, I gotta consider, you know, the placement of my stream and where I'm writing. 2, my comments. 3, the math. 4, how do I vocalize and explain the math that I'm thinking in a way that my viewers can understand. And then 5, being entertaining. That's at least 5 things. Okay, so why don't you just follow what RGPT is saying? Because he's not wrong. Yeah, I just don't get it. Okay. So here is a graph. So, you know, if you want for fun, you can visualize it because that's what you're having issues with. So why don't you just type it in if you want to. So e to the power of 2x blah 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 minus oh my gosh, okay, minus whatever this is, 1/2 x squared. My music is making you sad? This is just classical JRPG music. Great for studying and relaxing. High quality. PSP Forever 1, thanks. Anyways, so here is your graph. It looked like this. And as you can see, what RGPT is saying is like the 0.00 doesn't go through the graph. So you can't just plug in 0 and get like a specific tangent line. And I'm assuming they want this so that it's tangent for any value of x. So you just do what RGPT says, right? You find this derivative, which is going to be a function of x. So what is that called? F? Y? So let's just call it f of x instead. So take the derivative, and then the line is going to be, you know, y minus 0 times x minus 0. And then those zeros don't really matter, so then you just have this. Right? And then you keep simplifying and it's going to be one of these. No, it's not simplifying. Does it just end up as one of these? It needs to intersect with the curve. Where does it say that? Tangent to graph. Oh, I need to touch it. Ay. Yeah. So this equation need to touch f of x. In other words, that means that at some point, the y value of this line needs to be equal to the function's value. So that means that we have an equation. Well, then we can do a substitution, which means that f of x needs to be equal to f prime at x times x. And then you need to solve for x. Don't you guys have voice chat? Just go talk in the Discord. Oh, Snakestar has a thingy too. Which point on this graph is closest to 7, 0? Can you help me with this? Sure. So y is equal to x to the power of 1/2. So this is just a square root graph, right? Snakestar. And this is just a visual so that you kind of know what the question is asking you. So 7, 0 is right here. Now we want to find out which point along this line is the closest. In other words, it has the shortest distance. In other words, we're going to try to optimize. So this is calculus. Let's call it d, the distance, right? Now the distance between any 2 points, you can just write as, well, that's in your formula book, but it's Pythagoras essentially. It's the difference in the x's squared plus the difference in the y squared, square rooting. So it is, you know, the x value of the point minus 7 squared. Is this a paper 1, paper 2? And then the y value, which is square root x minus 0 squared, square rooted. Pedantic version, yeah, the 2 norm. Calculators allowed? Okay, so easy peasy then. Well, at this point you can just shove this in a calculator, but let's make this look a little bit prettier for the sake of making it easier to put into the calculator. So if you expand this, you're going to get minus 14, but you square a square root, so this is going to become 13. Oh, and this should be 49. And then this is 1/2, right? Okay, to optimize. Well, this just means we find the min, right? So you don't even need calculus if this is a calculator question, because you can just graph this and find the minimum. So just put this into, you know, your handy dandy graphing calculator. So what is that? X squared minus 13x plus 49 to the power of 1/2. And this should look like a straight line. Take off the 1/2. Yeah. Oh yeah, you were here for this before, right? If you want to find the minimum of a square root, then it's also just the minimum of this thing. And this is easier to find a minimum of because it's a parabola. So there's your minimum. So what does that mean? Which point do we want, right? So the x value is 6.5, but this is not the y value. This is the y value of this function, which is this is the value of the distance. So we take 6.5, that's our x value. And then of course to get the y value, you just plug it into square root x. So root 6.5? Don't you have to find the derivative first? No, you don't. Because this is a calculator question. Calculators can calculate minimums of anything just by, you know, doing this. If this was a non-calculator question, then the only way you could find the minimum in an efficient manner is to take the derivative and then set it equal to 0. And then you solve for x. But as a calculator question, those can calculate minimums as it is. So hopefully that makes sense. If you've paid attention to my streams, Snake Eater, you would know that paper 2 ones, I never use calculus to find minimums because graphing calculators can do it for you. Paper 1, different story. Then you need to use optimization. Do you want me to go through it using calculator? Yeah, what if I had no calc? Well, then you do exactly what you think you should do. Take the derivative of the inside only, otherwise it gets messy. So this is the big brain stuff, right? The minimum of the square root should be at the same x value as the minimum of what's inside the root. So it's way easier to take the derivative of this. Unless RGBT has some minor detail that's... Yeah, I know. I mentioned it. Yeah, so take the derivative of this instead of this, because this is gross. This is nice. And then, you know, equal to 0, solve for x. Easy peasy. You should get 6.5. Now, obviously, in the middle of an exam, you might not realize this. So it is easier, but it's still not that bad if you take this derivative. So let me do it this way, because that might be what you do in the middle of an exam. So you get 1/2, right? X squared minus 13x plus 49. And then you take this to the power of negative 1/2. And then you chain rule. So this becomes 2x minus 13. Oh yeah, and then by the way, RGPT's way is same thing, right? We take the derivative, so you get 2x minus 13. And then you set this equal to 0. So how do you solve this equation being 0? So first, write it in a nicer way. This is 2x minus 13 over 2 times the square root of all of this stuff. Now, how do you get a rational function to be equal to 0? How is a fraction ever going to have a value of 0? That will only happen if the denominator is equal to 0. Yeah, so you just ignore the bottom, and then you end up with the same equation. Either way, you get 13 over 2, which is 6.5. So honestly, this is how I would do it if I'm just like, you know, trying to speed run this, and I just don't want to think about things. I just brute force it. And yeah, okay, this one's nicer, but whatever, it makes no difference. You just ignore the bottom, right? This doesn't affect the value at being 0. So it makes sense? You're good? Subtracting? Oh. Okay. Where was I? Wait. Okay, burgers sold on a typical day. Veggies. Okay. Find the probability that more than 400 veggie burgers are going to be sold on a typical day. So, find the probability that, I don't know, let's call this a random variable b is going to have more than 400. Well, b is kind of a bad capital letter because that stands for binomial distribution. So I don't know, let's call it v for veggie. Okay, so this is a cumulative binomial distribution. We find the probability of selling, you know, whatever, and then we keep going. So probability of selling more than 400 is the same as saying 1 minus the complement of this, which is selling less than 400. Less than or equal to 400. Now the reason why we want a lower bound is because, again, at least for TIs, you can't do an upper bound binomial distribution. It needs to be a lower bound. But now that we have that, that's fine. So one minus binomial cumulative distribution function, so CDF. And then how many trials do we have? 600 customers. The probability of getting a veggie burger is 6.65. And then we are interested in up to 400. Okay, and then I think I put a 1 minus at the front, so this calculates the complement. Yeah. So there we go. 1.85. Yeah. Okay. Oh, by the way, I got distracted, but yeah, spike ball, lunchtime spike ball league. I'm down, but I'm not gonna be the one that organizes it. So one of you, whoever's motivated for this, go organize it. Cause I'll come out. I'll wear shorts, and I'll be ready. Okay, what's next? It is known that 44% of the customers who come to the burger shop are females, and that 75% of female customers buy a chicken burger. If we select a random person, no lunch, go hungry? No, get lunch first, eat lunch, and then we just play spike ball for the rest of the lunchtime. Or get an early lunch, because lunch pickup starts before actual lunchtime. Doesn't it open at like 10:30 or something? Or work up hunger, and then after spike ball you can pick it up in PM flex. Yeah, but you have class. I don't know, on Thursdays or Fridays when you don't have class. Spike ball is volleyball essentially, except instead of a court, you are surrounding a net. So you bump that spike into a like trampoline net on the ground, and then once you hit it into the net, it is the other team's turn to bump that spike it into the net, and then it returns back to your team, and then whoever can't get the ball wins a point. It's fun. Try it out with your friends, RGPT. It's quite popular with those of the alabaster complexion, which I'm sure there are a lot of in Alberta. Okay, you can't visualize it, so there's like a little trampoline on the ground. And then, you know, you have your teammates, and then they can stand around the net. wherever. And then you have the other team. And they don't have to stand separated. Like the green guy could stand here. But anyways, so they serve the ball. So it goes here, and then again, anytime it hits the net and it bounces out, it's the other team's turn to recover it. That's what I just said. People of alabaster complexion love this game. And you, I'm sure, have a lot of alabaster friends down in Alberta. Alberta. See? And then, so this is the serve. So now, it's the other job's team to recover the ball and then send it back to the other team. So you can do a bump set spike, right? So like 1, 2, 3 touch. So 1, and then you can pass it to this person, and then they pass it up into the air. And then like one of the other team members can spike it into the net. So let's say, like, you know, this person, orange person, let's say this person, right, jumps into the air, does a backflip, and then spikes it into the net. So now it's gonna hit into the net, and then it bounces over here. And then again, you just repeat back and forth until one person, one team can't recover the ball, and then they lose the point. It is quite fun. You should try it out. Anyways, what is this? We're gonna select a random customer. Find the probability that the customer is female and buys a chicken burger. So, the probability that they are female and they buy a chicken burger, well, that's going to be the probability that they're female, so that's 0.44, times the probability that they will buy a chicken burger if they're female, which is 0.75. So easy enough to calculate. And then I bet part B is a given conditional probability question, because they love those. So 44% times 75, which is 33. Bruh, you are a nerd though. Okay, part B. A male customer is selected at random. So this is actually a given. So we have a conditional probability. Find the probability that he buys a chicken burger. So we want to find the probability that this person bought a chicken burger given that they're male. So this is the probability that they're male down below, and then the probability that they buy a chicken and they're male. But I feel like we're missing information. Ah. So this is the probability that you're buying a chicken burger. This is part of the probability of buying a chicken burger. It's the part of the females. But we need this part, the part that buy the chicken burgers that are male. So if this is 0.33, and we know that the probability of buying a chicken burger overall is 0.54, then that means that the males take up that other part of that probability. So in other words, that's a 0.54 minus 0.33. So this is 0.21. And of course the probability that they're male, given that, you know, they were trying to be on topic with Tesla, but they fail with their heteronormative binary vision, is, I'm assuming 44 female means that 56 are male. So they do not have updated 21st century ideals. Yeah, bunch of bigots down at IB office. Disappointing. Again, what they're saying is the probability of being a male is a complement to the probability of being a female. But anyways, so put this in a calculator and then you got this. Not true? Very true. I bet you the people that run IB are a bunch of old white men. Old white men that suck. Smelly old white men. Okay, so this is point 375. Head of IB is a woman? Well, they can be bigots too. Don't say that, RGBT. I know you're kidding, but it's not really a funny joke. Okay, where am I? Oh, I'm done. Bring out the sexist? Well, you expose Snake Star. Shame on you, Snake Star. But then again, you're from Manitoba, and RGBT's from Alberta, and you guys are basically like, you know. You're not exposed to, or you're like the most behind in terms of like social justice issues, I'm sure, in Canada. Alright, time to check answers. Again, I unfortunately can't show you the website. So I'm going to check the answers off screen, like the answer key will be on my second monitor. And then I'll just tell you if my things were right or wrong. Remember my rules when you agreed to chat in my chat. No bigotry. No bigotry. Oh, Mormon colonies? I've heard that Mormons can make like a sick like food or something. Like the Mormon markets are pretty good. Okay, I messed up my answer here, which I thought was gonna be, yeah, messed up. So what happened? So you are supposed to make a system. Oh shoot, I didn't read the question right. It's the sum of the first 6 terms, so this is an S20, so that changes everything in these numbers. My bad. Breakout rooms? No, please. I hate breakout rooms. Never again. 6 terms, which means that this should be 3, and this should be 5. So this should be 6, and then this should be 15. The method was correct, like I said, right? You set up your 2 systems, and then when you solve it, you'll get the proper answer. Alright, Snake Star, good night. Try to be a better person in the morning. No more bigotry. See you later. Bigotry, sad face, yeah. No room for that in my chat. Okay, and then let's see. The radians here are correct. The area is correct, so that one's good. And I'm not gonna join the call because it's late. That's what I'm... And remember, this is a woozy vaccine edition, so I'm not in the best condition. Okay, alpha 1.03, good. They will pay this back in... Okay, what did I do wrong here? What? My method? My numbers are right. But for some reason, they got a different answer for t. Okay, I think I used Desmos for that, so let me use a proper calculator and see if I get a different answer. Where are my mods? They're here. You're perpetuating sexism by making a sexist joke. That normalizes it, even if you are just joking. Where am I doing? Okay, let's do the log. Okay, log base. My base is 1.03. The thingy should be 3 because it was triple. 37. It is 37. I'm not saying it's true. I'm just saying it's not something you really should be doing if you know, if you don't support the sexists. What's the word? I guess the anti-sexists? The feminists, I guess? Okay, what is wrong with my thing? It shouldn't be wrong. Maybe their answer key is wrong. I don't know. My method's correct. My things are fine. So I don't know what's going on. They get 42 years. And don't ask me how they get that. Method is correct. So let's move on. Mugen Train finally out on 9 anime? You can do whatever you want for your IA, as long as it's good. Okay, 5, 3. Inverse, yeah. Wait, no, inverse is here, yeah. Domain, or sorry, range right here, yeah. And then y equals 5, good. Okay, these are correct numbers, and then this is fine, so that looks good. Okay, 5.28 seconds, 30 centimeters. Here's my function. Yeah, that looks great. 12.8 seconds, that's fine. Oh, looking pretty good. Okay, what do we got? 2, we got 8, we got 8 and 32, we got k is 6, c is 20, that's fine. Period of g is pi over 3, that's right here. 2.52, 2.72, that looks good. If Mugen Train is subbed and on torrents, then I'll torrent it. And then there's a way that you can watch together on Discord, right? We should watch that on Discord together. I don't know. It was kind of an odd decision to make Mugen Train a movie. I would have made the next arc a movie, Red Light District. But I guess it also makes sense because now they have like 2 hours or 1.5 hours or however long it is to characterize the fire pillar, Rengoku, because he doesn't have enough characterization in the manga. So like certain parts of that Mugen Train arc in the manga kind of fall flat. Well, I want to avoid spoilers, so I can't really tell you. Basically, he just doesn't have enough character development in the manga because, you know, it just happens in the manga, the arc. No, you shouldn't start a spicy discussion. Okay, what do we got? 75, good. Standard deviation, where is that? Where did I write it? Oh, 8, right here. Okay, 0.168, that's fine. Okay, expected value, 83. Probability of being this thingy is this one, that looks good. Okay, let's see, 0.19, yep, 0.35, that's great. 390, that's good. 0.185, 0.33, 0.0375. Okay, and then that's the end of the exam. So overall, pretty good. One mistake from me, because I misread that sequence one. One mistake from them, maybe, because I swear their answer key's wrong, but I don't know. No, don't start this spicy thing that you're talking about if kids can't handle it. I don't need, you know, someone pulling up to my principal and being like, look at what happened on Mr. Whatever's chat on his Twitch. His students are talking about this spicy discussion. Then I get in trouble. I don't want to get in trouble. You didn't see what he DM'd me. You assumed what you think he know what he said to me. There's a difference. No, they're not ranting on RGPT. They're ranting on me allowing him to facilitate this discussion with students, which is different. I'm the one that gets in trouble because this is my stream. You're my students. You're talking about all this stuff on chat, my chat, so yeah. Not worth it. Anyways, so that ends the predicted papers from the very famous website that I cannot say, but it is very similar to TrainingTown. Thank you guys for watching. For those that are tuning out, like RGBT, make sure you look into Spikeball, it's fun. Otherwise, everyone else, have a good night. I'll see you guys on Thursday, I guess. Oh, and then Thursday, Sunday is probability days because my students have a test on Wednesday about probability. So we're probably going to go through Christos's 2 packages, probability or statistics on Thursday, and then the probability package on Sunday. Hello, I'm not 5 a.m. You came just in time for the end. So yes. Is there a review? Like, not a physical one, you just have the packages I gave you. I'm not gonna give you any more. Anyway, so that's the plan. So Thursday, Sunday, you know, if you're interested in the probability because you're one of my students or whatever, come on by. And I will see you all sometime later. Have a good night. Bye.